So now let's do question 1b. Show that the Laplacian is equal to 0. And by Laplacian, I mean the divergence of the gradient of g. So the gradient we see above is this, and so the divergence of this is just no bracket needed. It's like this. So our question is to show this expression that you see here, show that this expression is 0. So based off the gradient that we see above, take the partial with respect to x, take the middle function, take the partial with respect to y, and take that third function and take the partial with respect to z. And I'm going to assume we can follow this. I'll write out the details for x, but for y and z, I'm going to skimp out on the details. Okay, so we have this. And then we take quotient rule. I assume we know how to do that. So that's just, and after some simplifications, we get this. All over the bottom squared, so it's power 3. So if we have that for gxx, then gyy is going to look much the same, but instead of an x at first, you see a y. Everything else will remain the same. And I divide. And then for gzz, all over the bottom squared. So it's just power 3. No, it's 3 over 2. You square it, you get a 3. Okay. So now we want the Laplacian, and we want to show the Laplacian is 0. So let's take gxx plus gyy plus gzz and sum it together. Okay, so this is just going to equal, and after some factorizations too, nothing too difficult. 3x squared, 3y squared plus 3z squared. And I quickly point out this 3x squared, this 3y squared, and this 3z squared, that you could see over here, 3x squared, 3y squared, 3z squared. And I forgot to write down times 3. And if you notice, here I have a term, the negative of a term. Here I have another term, and here I have that same term. So I have it 3 times. That's why I have this minus 3. So if I take this big expression and I simplify, what I get in the numerator, I just get 0. And what I get in the denominator, I get this. And we recall the domain of G does not include 0. So the denominator is okay. Denominator here is acceptable. So this is equal to 0. And that's it for question B.